Hello and welcome to today's video. In today's video, I want to have a bit of a migration talk between Unity and Unreal, or Unreal and Unity. So this isn't like a video about basically this is a video, so if you're a Unity user and you want to try Unreal, or you're an Unreal user and you want to try Unity, I just want to compare some of the kind of differences of how each thing's set up and how you access the tools within each engine. And I've been wanting to make this video for a while, but then today I saw a tweet from someone who works for Unreal Engine, and they have put out this new page on their website, Unreal Engine for Unity developers. So if you'd prefer this video in written content, may as well just go read that. I will link it in the description below. But I'm going to show some of these written sort of concepts, and I might throw some of this up on screen or refer to that. But here is the plan that I had. So this is all Unity stuff on the left and all Unreal stuff on the right. So I'm going to try and work my way through this, just kind of comparing and contrasting the two different engines together. And again, this isn't like a which is better, it's just, this is what it is in Unity, this is how it works in Unreal. So you can make your own opinions, which one seems better if you want to try Unreal. Obviously, both of these engines are free to just download and play with. So with that said, let's just jump straight into it. So the first thing you will see for both Unity and Unreal Engine is the launcher for the engine. So on the left here, we've got the Unity Hub 3.2, and on the right here, we've got the Epic Games launcher. This comes obviously with the Epic Games Store attached to it, which is quite a slow store to load, unfortunately. So yeah, so that's the Epic Games Store. Then we've got our games library. And here is the actual Unreal Engine tab. So that's kind of, on the right here, we've got the Unreal version of the Unity Hub, essentially. So you can see that there's all these different sample projects. Obviously, there's the MetaHumans, the city sample, some other cool stuff. You've got the marketplace built right into the launcher, which I really like. Obviously, with Unity, you have to go to the Unity Asset Store website, but we'll cover this separately when I'm comparing the asset stores. We've got a library, which is similar to the Projects tab and the Installs tab. It's kind of combined both of those with the Unity Hub. So here we've got our engine versions. You can add many previous versions of Unreal, and we've got our projects. Whereas in Unity, we've got the projects tab here with our projects that we've been working on, and installs, which is the different editors we've got installed. And you can come up here and you can just see all you can really get is the most recent version of the engine. If you want to get any other version, you have to go to the archive and download it from the website. And we've got the pre-releases here as well. So we've got the beta version of 2022 and the alpha version of 2023. Which I have downloaded. I'm yet to play with. I'm kind of interested in digging through that. So yeah, that's the kind of hubs. We've also got over on news, you've got the featured content, and then you can see if we come down here, there's the blog, community resources, and what's unique to Unreal Engine is you get the source code of the engine. So if you want to do any engine kind of changes, you've got access to the source code, which you can then, compile it from source. You can do all sorts of stuff with it. You don't get access to the source code of Unity. I believe you can get in touch with them, and obviously if you've got a lot of money, you can get the source code for it. But with Unreal, you kind of get that out of the box, which I found really useful because you can dig into kind of all of the engine code and kind of see how stuff's working. Even if you don't want to make any tweaks to it, you can kind of easily see all of the stuff that makes up the engine. If we wanted to make a new project in Unity, we can come here and we've got, a few different core templates, sample templates, and then we've got our learning tab with different micro games. If we launch the engine for Unreal on the right, you actually have to launch the engine to get the project window. So this is the project browser, so you can either launch a new project from here, or you can come down to games, and then they've got obviously the first person, third person, top down, vehicle, VR and AR kind of core templates, or you can just make a nice blank project. And then obviously they've got stuff for film and TV, architecture and automotive. Obviously, there's less choice over on the left, but you can see that there is the third person template for Unity. and we've got our third person template for Unreal. So there are jumping off points in both engines. So that's how you would make a new project and get started with them. So let's actually jump into the editor. So I've got Unity 2021 open here, and we've got Unreal Engine 5 open here. So first off, let's make a new scene in both engines. So over in Unity, we do File, New Scene, and then we can choose from a few of the different ones. So we can make we'll get the standard URP scene. Let's create that. And we can choose somewhere to save it. So we'll just go Project, Standard, just save that there. So here's our default universal render pipeline scene, like the nice basic scene. And let me just close that, extract it. And we've got our game window here. And then over in Unreal, we can go File, New Level. So that's one of the differences in Unity. They're called scenes, and when you save them, they are scene assets. In Unreal, they are levels, and you save them as maps. And there's the open world template, or an empty open world, and then basic or empty level. So just to kind of get nice and simple, we'll open the basic one, and that opened nice and quickly. And obviously you've got quite a lot of nice stuff just out of the box that you don't seem to have in Unity, such as the clouds, and it just looks a bit nicer. And we can do, just so you can see the open world level, it takes a little bit longer to load. This is just a nice big open world for you to play around in, and you've got the new world partition tab, which is a new Unreal Engine 5 feature. But right at the gate in Unity, we have our scene view and the hierarchy. In Unreal, we have the scene view here, which I believe they call the level viewport. So that's the kind of technical term for it in Unreal. So we've got the scene view and the level viewport. We have the outliner here and the hierarchy here for Unity. And you can see here that we've got some things sort of in. So we've got the directional light and the directional light. So these are the same objects, kind of, they've both got transform, rotation, scales. Transform, rotation, scales. They have, they've got those. And I've just realized I wasn't filming in 4K, so sorry if the beginning part of this video was a little blurry. So we've got the directional lights, and the directional lights, these are objects within our scene that have a transform component with a location, rotation, and scale. And then we've got our light component, which has all of the sort of settings for the light, and you've got them over here as well in Unity. So like that, they are similar in that they've each got different sort of components attached to them. However, the kind of way this is all set up, so in Unity, we add game objects scene. So this is a game object that's in the scene, got a transform with position, rotation, and scale, but there's nothing else attached to it. In Unreal Engine, we have actors, not game objects. So we can go to the place actor panel, and we've got some basics, and we can just drag in a basic actor. So this comes into the scene, and this is just a basic actor, just like we've got game objects over here. But if I bring in a cube to our scene, we add a 3D cube to our scene here. So we've got our game object in Unity, and we can drag our cube to be a parent of our game object. And what's happening here is we are parenting the cube's transform, being parented to the game object's transform. So that's how we can get these hierarchies of a game object with things attached to it that now follow that game object as we move to the top level one. However, if you try and drag the cube onto the actor, you can't do that. What you actually have to do is in a actor, go this add button here, and you can add in a cube mesh component to the actor. So we go add, then we could search here for cube, and we've got basic shapes, cube. So now this actor has a cube component attached to it. But this cube itself isn't a game object. It's a component of our actor. Whereas this cube here, our cube that's attached to the game object in Unity, this is its own game object. We can break this off, and then it's its own separate entity with its own transform. Whereas if we click on our cube in Unreal, it does have its own transform, so we can translate it locally away from our cube. We can't snap that off and then drag that into the scene sort of separately. It's just attached to our default scene root here. And again, on this new thing, this new page that got posted, the Unreal Engine Migration Guide, you can kind of see that here. So we've got a game object which has a transform, and we have a game object which has a transform, and these transforms have been parented together. So this is our cube, this is our empty game object. We've parented the cube's transform to the game object's transform. Whereas in Unreal, we have an actor, which has a root component, and then that has various scene components, and you can attach scene components to scene components. So it's a little bit different like that, but it is similar in terms of how stuff can be parented together. Instead of creating empties, you add them all to the top level actor. So if we delete this, we can actually add a scene component, which is called scene here, and add our scene component, and then again this has its own location, rotation, and scale. But then to this scene component, we can now add a cube component, and you can see that that's parented now to this scene component. So the hierarchy is still kind of the same as Unity. So in Unity, we've got a cube parented to our game object. If we wanted, we could create an empty parent, and in the kind of translation between Unity and Unreal, this game object would be similar to this scene component, and then the top level game object is similar to this actor instance that's in the world. So hopefully that kind of all made sense. It felt a bit rambly saying it, but hopefully it did make sense. So the next thing is, let's talk about prefabs. So if we go over to our project, and we'll go into this prefab folder here, and actually let's bring back our game object cube just to keep it all nice and tidy, and kind of using the same examples. So we've got our cube here. This is our game object, and I can drag this down here into our project window and make a prefab folder, and we can see a preview of our prefab down there. If we get our actor back, and I'm just going to zero out these. So here we have our actor, and unlike Unity, you don't just drag this into your project browser or content browser. You can click this little button here, and this will make a blueprint from selection. And we can choose what we want this to derive from. Do we want it to be our top level actor, or does it want to be anything else, any other class that it can inherit from? But we're just going to keep it simple with the top level actor component, and I will save it just in our root content folder, and then I can call it just actor blueprint. I'll leave that all the same. And now you can see we've got our actor blueprint here. So if we open up our game object prefab in Unity, you can see that we've got a similar kind of layout. So on the right here, we've got our details panel. We can manipulate all of the details about our objects, and we can move them around. And it's the same over here with our prefab window. One thing that you will notice with Unity and Unreal is Unreal snaps off these individual windows. We've got our actor blueprint, which can be its own window. We can drag that to another screen if we want. Obviously, you can drag these to be free floating, but this is just reusing our scene view tab, which we can snap back on there. And by default, prefabs will just open in the scene view. If we open up another scene view, you can see that it's still our game object. This isn't our, we can't go back to our scene. You know, these are kind of linked. We've got our main scene view and our thing, but they're not working correctly. Weird. Yeah, we've got our prefab editor and our blueprint editor. But now, just like in Unity and within Unreal, if I go back to our game and then we can drag in our game object prefabs, just as we can drag in our actor blueprints. And if I go over to our actor blueprint and then I say duplicate this cube, bring it up and scale it down. Then if I go into our game object prefab and duplicate our cube, bring it up and down. Then we go back to our scene view. You can see that that's reflected here. And if we go back to the Unreal level viewport, you can see that's reflected there. So they do kind of work. They work quite similarly. But one thing that you will notice, I'm saying actor blueprints, and obviously blueprints is Unreal Engine's visual scripting language. So we can go, every blueprint has a blueprint graph. Whether you use it or not, you may not use it, you may not want to do sort of any logic whatsoever. But that option is there for very quick prototyping. So if I wanted to get this cube, I could bring this in and we could add local rotation. And I'll do this in the tick, and let's just add 5 in the Z. We can compile that, go over, and if we hit play, we'll see that they start spinning. So this is all weird because I've set up, this is in a custom project I've got, so just ignore that. But you can see how easy that was to get something manipulated on our blueprint. And we can go back, tweak that, change it, come back, and then, you know, it'll be fine. Whereas in Unity, with our prefabs, obviously there's nothing like that. What we'd have to do is add a component, and then we could add a new script, or if you wanted to use Bolt, they do have a visual scripting language, but it's not built in and integrated as well. So we'd have to make a new script, you know, make the rotate script, add it, and then code in that logic. And obviously that takes a bit more time, and then you've got to let that script compile to get back into play mode in Unity. And you saw even then I haven't added any scripts, and each time it wants to reload script assemblies and then jump in. Whereas in Unreal, we hit play, we're in, and it's doing it nice and quick. So one of the other differences now I want to move on to is the kind of difference between the scene view and the project viewport. So the level viewport, sorry. So we've got our project view here, and you'll see that as soon as I click play, it snaps to the camera position, and I have to stop to get my scene view back. Whereas in Unity, we hit play, and we've got our game window down here, and we've got our scene view, and if we manipulate anything in our scene view, we can move stuff around kind of live, and we can see it reflected in our game camera. If I hit play to come back out of that, it obviously doesn't save any of the changes. Now in Unreal, once you're in play mode, you can't see your scene view and the game mode at the same time. So if we hit play, you can see now that it's snapped to our camera, and we can press F8, and then we can see our scene view, and we can, then we can manipulate stuff. But you can't have a game view window up at the same time as being in your scene view. So this brings us on to another concept that is a bit different. Whereas in Unreal Engine, a player has a player controller, and that possesses a pawn, a PAWN pawn, like a chess piece pawn that you can move around on the, which you can then manipulate, move around in the world. That logic is kind of there. Obviously, Unreal Engine was developed to help make multiplayer shooters, so everything's kind of got language geared to that. So there's a controller which is controlling a pawn which can move around the world. But there's no sort of concept. No similar concept in Unity of controllers possessing pawns. You've just got a camera which is focused on an object, and then you decide what happens with that object. If you want to move it around, have to code that logic to move that item around. Then you have to get the camera to follow that object in the world. You have to decide what a character is. Whereas in Unreal Engine, you've got a game mode which has access to different pawns, player controllers. You can swap out one player controller, could be driving a car, and then that car is a pawn, and then they can get out of the car, and then suddenly they are a player character, which is a type of pawn which can move around the world. So this is one area where it's not one-to-one. You can't, there's no direct comparison there. Unreal Engine just has more stuff to make a game out of the box. Unity is obviously very bare bones, and that's one of the features people really like about it. It means it's quick and it's light and it's not bogged down with stuff that you don't need. If you need anything, you can either make it yourself or get an asset to do it. Whereas Unreal Engine does have a lot of default classes out of the box. So if I right click, create a new blueprint, you can see here that we've got actors, pawns, characters, controllers, game modes, actor components, scene components. If I spawn in if I make a new character blueprint class, you can see that it comes with a capsule, an arrow to show you which way it's moving, a mesh component, which I don't really have any skeletal meshes that kind of make sense. There's this one for the dice project I've been working on. And then you can see that we could now drag that into the world, and this is a character that our player controller can possess. These actor components, this character class comes with a character movement component, so it's really easy to just move it and change all of the gravity and scale and stuff. Obviously there's none of that in Unity. We'd have to make that ourselves if we wanted to manipulate our character. Okay, so another bit of a difference that's probably going to catch a few people out if you make the jump between engines is that over here you'll see that with the gizmo, and you can't really see it there. Let's do something else. So we've got this gizmo. So you can see here we've got our gizmo, and you can see that we've got the X is pointing forward, we've got the Y is pointing right, and the Z is pointing up. So the colors are the same in relation to kind of their position. So RGB, X, Y, Z. That's kind of how it follows. So we've got the X-axis is the red. But you'll notice that that is the forward axis of our game object. So let's just center that and bring it forward. So if I wanted to move forward in the world, this is kind of how we'd be aligned. So the X-axis is the forward, the Y is the right, and the Z is the up. And you'll notice, so I'm here in Blender, the XY plane is the kind of left and right, and then we add in a cube, Z is up in Blender. Annoyingly, I think it's the Y direction is forward, but we've got XY on the plane with Z pointing up, which matches Unreal. But you see in Unity, we've got our Z, which is the forward direction in 3D. X is the left and right, and Y is up and down. So if you're manipulating something in Unreal or Unity and you're used to the other one, it can get quite confusing. If I wanted to make this object travel on its forward vector, I would need to manipulate the Z component of the vector 3. Whereas in Unreal, if I wanted something to move forward on the forward in Unreal, I would have to manipulate the X value of the F vector, which is Unreal's vector 3 struct. So that could catch you out. It's a bit confusing. I quite like that it translates a bit more to Blender as opposed to Unity. A lot of the time you'll make something in Blender, import it into Unity, and it'll be upside down, or it'll be led on its back. I believe the reason for this being Y is up and X is left and right, if you translate that to 2D, which Unity is always been really good at making 2D stuff. Obviously that makes sense. You run before you fly. So in that case, it kind of makes sense. And if we come out of 2D, you can kind of see that correlation. So we've got X is right, Y is up. And then if we come out of 2D, we add the third dimension to become the new kind of forward, and then that leaves X and Y to stay as up and right. Whereas Unreal has always been designed with 3D, like kind of, from the outset. So we've got X is forward, Y is right, and Z is up. So let's try now to make our cubes a different color. So in Unity, you have shaders, and then you make a material from a shader. In Unreal Engine, you make a material, which is like the shader, and then you make a material instance, which is like the material in Unity. So I'll show you what I mean. So using shader graph in Unity, we can right click, come down to shader graph, do a URP, and make a lit shader graph. We'll just call this lit test shader. So we've got our graph view here. Make some room. So we've got our graph with base color, normal, the metallic, the smoothness, the emission. If we right click, create a material, and we'll call this the test material, and then we can open this up in the editor, and you can see there's some stuff here. So there's the base color, the metallic, it's roughness based Unreal. So like if you put a value of 1, that would mean it was very rough, so it wouldn't be smooth. And over in Unity, if you put a value of 1 into smoothness, it would mean it's not rough at all, it's fully smooth. So that obviously gets a little confusing. So we put 0 roughness in here, we get a really shiny object. If we put 0 here, and we move our graph in vector, we get a really rough material. Whereas if we put a 1 in, we get a really shiny material. And if we put a 1 in here, we get a really rough material. So that's a difference just in the terms of the way the materials and shaders work, which is, a little bit, which, could be a bit confusing if you're trying to recreate the same scene in Unreal and you're kind of putting in these values without really paying attention. That could catch you out. And then we have our base color. So let's just make a constant vector 3, and we can drag this into our base color and say make this. We'll make it green, nice greeny color. So there's our base color in our test material kind of like node output, and we can see that here in the preview window. And this is quite a nice little preview window as well. You can see that we've got a HDRI. It's kind of a nice like look dev environment. We can come up to the window, come to the preview scene settings, and if we wanted to, we could hide the environment, could show a floor, we could change the background to be a nice color. You don't really have any of that over in shader graph. You've just got this bit of a boring window. The most you could do is swap out the preview mesh, which again you could do that here in Unreal as well. You can swap out the mesh. Let's turn that environment back on. So we've got our test material here, and if I convert this to a parameter, we could call this our base color parameter. And in Unity, we can change it to a green color here if we wanted, or we could come up to here and make a color parameter and then drag in here and drag the color in, and we can set a default value of green, and we can save our shader there. So let's just jump back over to the scene view, and we'll save that and close this. So we've got our material, and you can just drag a material straight on to an actor if you wanted. But if we open up this material, you see it opens up this window again, and then we could just change the color here if we wanted to make it a different color. And then if we hit save, that would reflect obviously in the world. If we wanted to drag our shader onto one of our cubes, you can't do that because this is just a shader file. What you need to do is right click, create material, which this isn't very well organized. Where we material, and now you can see that we've got our preview window. Then we can drag our shader graph material on here, and you can see that we've got our color input if we wanted to change the color. That's up here now on our actual material, which presents these parameters. Whereas now, if I right-click our test material, we can create material instance, and we can call this test material inst. And if we drag this as to replace the test material on our cube, and then if we make another material instance, and we can drag this onto cube 2. So you can see with this material here, we can double click it, come over to the details, and we can change the color if we want to. So we can get our base color, and we could make this pink or purple. And then we could save that instance. And if we go back to the window, you can see that has changed there. And because our inst was an instance of an instance, you can see that that's changed, that is filtered down. But we can set a different parameter just for that instance. So you can have these like childed instances to this top level material. And now if I went back to the material here and then we made it not rough at all, that'll make it nice and shiny. So we can apply that. And you can see that that's changed for our material instances as well. But again, I can convert this to a parameter. I'll set the default value to be a slider between 0 and 1, and we'll hit save. And now in our material instance, I can change this to be fully rough, and I can come to my instance, so the child of that, and I could make that one smooth. So you can see that's quite powerful to do these kind of changes. If you wanted, you could just have, if you wanted, you could just make another material instance of the actual material top level, the shader for lack of a better word. And we could then, drag this onto our cube instead. And we could just change this one independently. And you can see the parent is our test material. That's the top level shader. So now, if we change this parameter, that will only affect that instance of it and not the other. Whereas in Unity, you see that we've just made another material, having right-clicked this material, and it's not parented, it's just a new separate material, and it's not even linked to our lit test shader. We'd have to then come up to our lit test shader here, and now that shader is that shader, and we can change the color independently. So that's kind of how the difference in materials works across Unity and Unreal. Okay, so that's a big info dump about the editor and how it uses and the kind of architectural differences between them. Hopefully that wasn't too rambly and you managed to follow along. Again, that article that they put out is really good explaining these differences if you wanted it in a visual form. But now I'm going to move on to some other stuff. So we've got in Unity, we have a package manager, which has a large range of built-in packages, they call them. Whereas in Unreal Engine, we have plugins, which, for all intents and purposes, they are packages. And you can see there's quite a lot of built-in plugins that you can enable or disable, just as there is with Unity. And go to Advanced Project Settings, we can enable pre-release packages, and that, that lets a few more show up, not a huge amount show up. Yeah, you can see there are a lot of packages or plugins in Unreal that you can enable, such as the Chaos Editor, Bridge, Megascans, Blueprint stuff. So that's some sort of differences. If you want to kind of manipulate the engine and expand its features, you can get plugins or you can get packages. And you don't have to, obviously, with either of them. You can add packages from disk or from a Git URL. You can make plugins directly yourself within the plugin editor in Unreal Engine if you want to add. And you can get plugins or packages from the Asset Store or Marketplace, respectively. So they work quite similarly in that they allow you to customize the engine and add new features that you require to the engine. And you're not getting bogged down with stuff that you don't need. And I mentioned there the asset store or the marketplace. So if we go over to Unity Engine Asset Store, we have our asset store for Unity, which looks like there's a sale on, which is good. So we've got our time-saving assets here. If we go over to the launcher, we can go to the marketplace, and you can see we've got all of our different marketplace assets here as well. And again, you can browse them sort of as you do with Unity, 3D, 2D, megascans, UI, textures, etc. Unreal Engine have got really good free content. Like that banner ad that opens it up in the web browser version. So here's all of this month's free stuff. They also have a permanently free collection, which is really good. There's loads of stuff in here that you can just get for free and add on. I don't think there's anything like that over on the Unity Asset Store, but that's just something to consider, that Unreal has a lot of good free stuff. Yeah, there's the Asset Store and the Unreal Engine Marketplace. There's a lot more stuff in the Unity Asset Store, and it generally seems to be a lot cheaper in my case, in my kind of time playing with it. You can get a lot of really good stuff in the Asset Store, and in fact, I think you have to rely on it a lot more in with Unreal Engine. Whereas in Unreal, they do have stuff. They've got edited changes. Sound packs, and a lot of the big sort of asset makers will make stuff for both marketplaces as well. So if you go, there's the Polygon shops pack from Cinti, and we go over here to the Polygon shops. You can see they've got it over here as well, and it's on sale on Unity. And the final thing I want to cover is the documentation. So if I go over to and if we look at the Unity Engine Vector 3 manual for the page, and if on the right hand side get the Unreal Engine F Vector documentation, open up this. So first thing you'll notice is Unity documentation is just nicer to look at. I feel like it's laid out a lot more sort of nicely. And if we come down on the right, so we've got, let's look at the method. So if we've got function, as it's called in C++, so we've got something here called, here we've got F vector cross product. So we can click into this. And if we've got the cross product over here, you can see that in Unity, we've got a very nice description of what's going on. As pictures, and then most importantly, I think, example of how it's used in code. We've got a bit of code that we could copy and paste into our project and actually see it physically working. In Unreal Engine, there isn't really anything of that. It just tells you what the parameters are, and it's very unhelpful. The first vector, the second vector. Obviously here we've got commented code as well, so get the normal point of the triangle, and that's the case on kind of all stuff. So if we go to distance, again there's an example bit of code in distance in Unreal, no example code, it's just static float dist. It's just kind of how the method is set up. It doesn't show you actually how you would use the method in kind of any useful kind of case, and that's just a very small example. But the deeper you dig into kind of features that you want to learn, the kind of worse and worse it gets, especially if you wanted to do so like Unreal Engine line trace, sorry. So here is another sort of better example. So we've got our physics.raycast, which in Unity we do a lot. In Unreal we do them a lot as well, and it's actually a line trace, they call them in Unreal, instead of a raycast. But in the documentation for this on the left, we've got the declaration, the parameters, what it returns, a description, and then not just one but two different ways of using it in an actual script. And again, what you've got over on the right hand side from Unreal is just kind of the definition of the actual method. It doesn't show you how to use it. This is quite a common thing that you would do in Unreal. You need to look up something, and then you find out that, oh, okay, I need to do a line trace. How does that work? So then, if you go back, you can see even here, unlike Unreal Line Trace C++, there's a forum entry, and someone from the kind of community back in 2014 has had to put this sort of together to show how that works. And that's not always the case. Sometimes you will come across a forum post, it's got no kind of results on it. They've put a big post together, someone's asking for help, no one's replied. The Unity forums are usually a lot better, but sometimes you don't even need to go there. You can just go to the documentation and actually see how a function works. Yeah, that's just some of the different kind of base level migration stuff that I wanted to talk about when comparing Unreal Engine and Unity. I hope this was useful. If it was, let me know in the comments down below. If you want to see any other sort of deep dives, like a C# versus C++ kind of translation guide, let me know. I'd be happy to do that. But yeah, in the meantime, thanks for watching, and I'll see you in the next one. Bye.